everyday science behind household objects. Have you ever stopped to think that your home might be one of the most advanced laboratories in the world? Every switch you flip, every appliance you use, every small action in your daily routine is powered by centuries of science quietly working behind the scenes. From the hum of your refrigerator to the shimmer of your mirror, your house is alive with physics, chemistry, and engineering. You don't see it, but it's there, shaping your comfort, your safety, and even the way you experience the world. Today, we're taking you on a journey through the invisible science that powers your everyday life, the extraordinary hidden inside the ordinary. The story of light. Let's begin with something so simple you might not even notice it anymore. The light bulb. A small glass globe that turns darkness into day at the flick of a switch. But inside that bulb lies one of humanity's greatest inventions. When electricity flows through the bulb, it encounters resistance in a thin tungsten filament. That resistance turns electrical energy into heat, and heat into light. Tungsten can withstand temperatures hotter than molten lava without melting, which is why your bulb glows bright for hours. But most modern homes no longer rely on filaments. Instead, they use LEDs, light-emitting diodes. These work not by heating metal, but by moving electrons through a semiconductor. When an electron jumps between energy levels, it releases a photon, a tiny packet of light. No wasted heat, no fragile filament. Just pure, efficient light born from quantum physics. And when you flip that switch, you're not just turning on a bulb, you're commanding a flow of electrons through copper wires, a concept discovered nearly 2 centuries ago by scientists like Michael Faraday and George Ohm. Your home, in that moment, becomes a cathedral of controlled energy. The chemistry of clean. Move to your bathroom or kitchen and you'll find another marvel. Soap. Something so simple yet so brilliantly designed. Every soap molecule is a double agent. One end loves water, the hydrophilic head, and the other hates it, the hydrophobic tail. When you wash your hands, those tails latch on to grease and oil while the heads cling to water. The result? Tiny bubbles called mycelium, with dirt trapped inside. When you rinse, the water pulls the mycelium away, taking the grime with them. The same chemistry powers your laundry detergent, dishwashing liquid, and even shampoo. Each one is an elegant dance between water, oil, and surface tension. Some formulas use enzymes, biological catalysts that break down proteins and fats at the molecular level. Others balance pH to protect your skin or hair. You might think you're just washing your hands, but in truth, you're commanding a microscopic army of molecules in perfect formation. The refrigerator, where thermodynamics lives. Now step into the kitchen, the heart of the house. Look at the refrigerator. To you, it's a cold box. To a scientist, it's a battlefield of thermodynamics. Contrary to what we often think, refrigerators don't create cold, they remove heat. A refrigerant fluid inside the coils absorbs heat from the food compartment as it evaporates. Then, a compressor squeezes that gas, raising its pressure and temperature. The hot vapor passes through condenser coils, releasing heat into the room before returning to liquid form. It's the refrigeration cycle, a perfect loop of physics that defies intuition. Your fridge doesn't freeze your milk by creating coldness, it does so by moving heat somewhere else. Every hum of that compressor is a quiet reminder of human mastery over one of nature's most stubborn forces, entropy. The microwave, cooking with invisible light. Now open your microwave. Inside that ordinary box lies one of the most fascinating uses of electromagnetism in your home. Microwaves are a form of electromagnetic radiation, similar to light but with longer wavelengths. When the magnetron inside your oven generates these waves, they bounce around the metal chamber until they strike your food. The waves make water molecules rotate millions of times per second. That rapid rotation produces friction, and friction generates heat. It's called dielectric heating. The food warms from the inside out, not from an external flame. The glass turntable keeps things even. And that mesh on the door? It's a Faraday cage, a shield that keeps the radiation safely inside while letting visible light out so you can see your food cooking. Invisible waves, tangible results. Science at its quietest and most delicious. The ceiling fan, turning current into wind. As you walk into the living room, a fan whirs above your head. Simple, right? A motor, some blades, and a switch. But behind that breeze is the story of electromagnetism. When alternating current flows through the coils of the fan's motor, it creates a rotating magnetic field. That field tugs on a rotor, the part that spins, and with it, the blades. The shape of the blades forces air to move downward, creating a pressure difference. The air movement doesn't lower the room temperature, but it speeds up the evaporation of sweat from your skin. That evaporation absorbs body heat, making you feel cooler. It's not cooling the air, it's cooling you. A perfect partnership between physics and biology.
The screen in your hand. Now look at your phone or your television. Glowing rectangles that connect you to the world. Inside them lies the art of modern optics. A screen is made up of millions of pixels, each containing red, green, and blue subpixels. By varying the intensity of each color, your device creates every image you see. LCD screens use liquid crystals that twist and untwist under electric current, controlling how much light from a backlight passes through. OLED screens, however, use organic compounds that emit their own light when electricity passes through them. No backlight needed, just pure, vivid color. And when you touch the screen, capacitive sensors detect the disturbance in an electrical field caused by your conductive finger. The phone instantly knows where you pressed. Every swipe, every tap, every image, it's electrons, photons, and precision engineering working together to connect you to everything. The iron, flattening with molecular control. Your clothes iron is another unsung marvel. When current passes through its heating element, usually made of nichrome, it resists the flow, heating up. That heat travels to the metal plate, which glides over fabric. As heat reaches the fabric, it breaks hydrogen bonds in the fibers, allowing them to relax and reshape. Pressure flattens them into smooth lines. When the fabric cools, new hydrogen bonds form, locking the new shape in place. That smooth shirt isn't just the result of heat, it's a molecular rearrangement you perform every morning. The clock. Time from vibrations. Look at your clock. Whether digital or analog, it's powered by rhythm. The rhythm of physics. In a quartz clock, a small crystal vibrates at exactly 32,768 times per second when electricity passes through it. Those vibrations are counted by a circuit and translated into seconds, minutes, and hours. It's so precise that the entire global time system relies on the same principle, scaled up with atomic clocks. Every tick you hear is the sound of vibrating quartz, a reminder that even time itself in your home is measured by science. The mirror and the window. A mirror seems simple, but it's a masterpiece of optics. Light hits the glass surface, coated with a thin layer of metal, usually aluminum or silver, and reflects back almost perfectly. Glass, meanwhile, isn't a true solid. It's an amorphous solid, atoms frozen in a random arrangement, like a liquid that never settled. That structure allows most visible light to pass through, while blocking ultraviolet and infrared rays. So when you look out your window in the morning, you're actually looking through centuries of scientific craftsmanship, from Roman glassmakers to modern engineers who learned how to manipulate transparency itself. The magnet on your refrigerator. That tiny magnet holding a photo on your fridge is a piece of atomic order. Inside, millions of microscopic magnetic domains are aligned in the same direction. In materials like iron or cobalt, the magnetic fields of atoms reinforce one another, producing a permanent magnet. The fridge's metal surface, containing iron, lets those domains interact, sticking the magnet in place. It's the same principle that guides a compass needle north, stores data on hard drives, and generates electricity in turbines. Every magnet in your home is a silent ambassador of quantum mechanics. The kitchen flame. Turn on your stove and blue fire dances. That flame is chemistry in its purest form. Natural gas, mostly methane, combines with oxygen in the air to produce carbon dioxide, water vapor, and heat. It's called complete combustion, clean and efficient. The blue color comes from excited CH radicals emitting light at specific wavelengths. If the flame burns yellow, that means incomplete combustion, a sign of unbalanced air supply, which produces carbon monoxide. Even that color shift tells a chemical story. In an induction stove, the process is even elegant. Alternating current creates a magnetic field that induces electric current directly into your cookware, heating it from within. No fire, no waste, just controlled electromagnetism in the service of dinner. The washing machine. A washing machine looks mechanical, but it's built on principles of motion and balance. During the wash cycle, the drum spins and agitates, creating turbulence that loosens dirt. Detergent molecules surround the particles, forming micelles that keep dirt suspended in water. In the spin cycle, the drum rotates at high speed. The water is forced outward through tiny holes. That's centrifugal force in action. Modern machines even sense vibration and adjust the spin automatically, thanks to accelerometers, the same type of sensors used in your smartphone. Each load of laundry is a study in physics, chemistry, and artificial intelligence.
The air conditioner. When summer heat fills your home, the air conditioner fights back with the same science as your refrigerator, but on a larger scale. It compresses a refrigerant gas, then releases it through coils to absorb indoor heat. The warm air passes through the evaporator where the refrigerant cools it down. Fans circulate the chilled air, while filters trap dust and microbes. The system doesn't add coolness, it extracts heat and moves it outside. The more you understand it, the more incredible it becomes. A machine that literally bends thermodynamics to human comfort. The pressure cooker. On your stove, the pressure cooker demonstrates the power of gas laws. When steam builds up inside the sealed pot, the pressure rises, increasing the boiling point of water. Instead of boiling at 100 degrees centigrade, water now boils closer to 120 degrees centigrade. Food cooks faster because the higher temperature breaks chemical bonds more quickly. It's Gay-Lussac's law and Boyle's law right in your kitchen. Ancient science wrapped in stainless steel. The toothbrush and toothpaste. When you brush your teeth, you're using both chemistry and biology. The toothpaste's fluoride ions strengthen enamel, creating a tougher layer called fluorapatite. Abrasives like calcium carbonate polish the surface, and antibacterial agents kill harmful microbes. The nylon bristles on your brush are perfectly engineered polymers, flexible yet strong, born from chemical innovation in the 1930s. That simple daily habit is a collaboration between human hygiene and molecular science. The Internet Router. You might be watching this very documentary through an invisible network of radio waves. Your Wi-Fi router converts digital data, bits of ones and zeros, into electromagnetic signals. These signals travel through the air, bouncing off walls, reaching your devices. Each packet of data is encoded using modulation techniques, adjusting frequency, phase, or amplitude, just like how your favorite song is carried on a radio wave. Invisible energy, visible connection. The language of physics spoken by your devices. The doorbell. A doorbell is one of the simplest but most elegant demonstrations of electromagnetism. When you press the button, current flows through a coil of wire, creating a magnetic field that pulls a small metal hammer. The hammer strikes a chime. Release the button, and a spring resets it. Every ring of the doorbell is a mechanical symphony directed by electricity, the same principle that drives speakers, headphones, and motors around your home. The sink and water flow. As water flows from your faucet, it follows Bernoulli's principle. Faster flow equals lower pressure. That's why the jet of water narrows as it falls. When it spirals down the drain, you're watching angular momentum conservation in action. The Coriolis effect can even influence the direction of that spin, depending on your hemisphere. Fluid dynamics, gravity, and geometry all at play in a single moment of washing your hands. The battery. Hidden inside every remote control, flashlight, and phone lies another wonder, the chemical battery. Inside, two metals separated by an electrolyte undergo a redox reaction. Electrons flow from one side, the anode, to the other, the cathode, through your device, providing power. Rechargeable batteries reverse that reaction when plugged in. Lithium-ion types even move charged particles between layers of graphite and metal oxides, storing energy in atomic spaces. That little cylinder on your desk is not just a power source, it's a chemical engine that shaped the modern world. The fire alarm. Your smoke detector is a small guardian of physics and safety. Ionization-type alarms contain a tiny amount of americium-241, which emits alpha particles. These particles ionize the air inside the detector, allowing current to flow. When smoke enters, it blocks the flow, triggering the alarm. Optical smoke detectors, on the other hand, use light sensors. When smoke scatters the beam, the circuit detects it and sounds the alarm. Whether through radiation or light scattering, your safety depends on pure scientific precision. The hidden laboratory. Now step back and look around. Every corner of your home, every click, hum, and flicker tells the story of human curiosity turned into reality. Your house isn't just a living space. It's a gallery of applied science where chemistry keeps you clean, physics keeps you cool, and engineering keeps you connected. We often marvel at rockets, robots, or space telescopes, but the truth is, the same laws that guide them are already here, inside your home, working quietly every second. The beauty of science isn't only in the extraordinary, it's in the everyday. In the light that fills your room, the water that runs from your tap, and the invisible forces that shape your comfort. The more you notice them, the more you realize your world is built on wonder.